Yeah, so let's start with today's session. Okay. So today's the week 6 of this phase 2. So today I'll be covering steel structures. So specifically the resultant stresses and forces on bolts and fillet welds. Okay, so this is the main thing I'm going to cover today. So it's very important topic of steel structures. So first of all, let me give you a brief overview of what I'm going to cover today. Okay. So first of all, there's one question from GATE 2017 related to resultant forces in the bolt. Then I'll be covering one question from GATE 2018. It's a very similar question to that which came in 2017, force in bolt again. Okay. So next I'm going to cover one practice problem. Okay, so in this practice problem, very similar to this. So if you'll carefully see problem 1 and 2, then you'll be able to solve this practice problem. Okay, so please sit with your pen and paper. Then there's one question from GATE 2019 related to resultant stress in weld. Okay, so as you can see, this is a very common topic from steel structures, resultant forces or stresses in bolts and welds. Okay, so it's a very important topic and questions are very simple. If you follow a certain pattern, then you'll be able to solve the problem. Okay, just you need to follow the steps. Okay, so let's start. So first question is question number 43 of GATE 2017. It's a 2 mark question and fill in the blanks type. Okay. So in the fill in the blanks type of question, as I always say, please see the units and the decimal place in which you have to give the answer. Okay. So in this question, there is a column. Okay. So this is a column and this bracket or this kind of plate you can say is attached to the column using these 4 bolts. Okay, if you want to see it more clearly, then I can draw it in 3D. I'll try to draw it. Okay, so this is the column. This is the column and there is one bracket plate which is attached to this column like this. So this is the plate. Yeah, so this is a kind of plate which is attached to this column with the help of 4 bolts. Okay, so this is the scenario. Suppose this is the CG, the center line of this system. CG of the board is here. So this is the CG of the bolt system, and there is a load, applied load P. Okay, the distance between this center line to the applied load is E. Let's say E is the eccentricity. E is the distance between the center line and this applied load P. Okay, so what happens it is in this system, because of this applied load, 2 types of forces will generate. The first one is because of this applied load P, each bolt will have one downward load in the, that is the force in the direction of the load. Okay, because of this applied load P, each bolt will be subjected to this downward force. Okay, that is the one thing. Another thing is this system is at a distance of E from that applied load. Okay, so because of this eccentricity, there will be a moment also, because whenever there is an eccentricity, that is there is some distance between the center line. Like when in the last class I told you, when there was a distance between the neutral axis and the applied load, that then because of that eccentricity a moment will be developed. Oh, I'm so sorry, I'm so sorry. Okay, is it fine now? Is it fine, Harini? Yeah, I'm so sorry for that. Okay, so I'll start from the beginning. Okay, so in this case, there's a column. Okay, there's a column here, and there's a bracket. Okay, so this is a bracket, or you can say a kind of a plate here. Okay, so I draw this system in 3D. Okay, I draw this system in 3D. So here is my column, and a bracket plate is attached to it. The distance between, so this plate is attached to this column with the help of 4 bolts. Okay, so we placed the plate like this and we attached it using these 4 bolts. Okay, so because of this, what happens is there is an applied load P here. Okay, so because of this applied load P, there will be direct force and there will be moment. Okay, so this applied load P was in downward direction, so because of it, every bolt will experience a load in downward direction. Okay, because of this applied load P. Okay, if that load would have been like this in upward direction, so then every bolt would have experienced a load in upward direction. Okay, so one is that direct force. So since this load is in downward direction, so every bolt will have a force in downward direction. Next, another thing is, like I told in the previous class also, whenever there is some distance from the CG or from the neutral axis, then what happens is, because of this that eccentricity, a moment develops, like I told in the last class also. So in this case also, there is this is the central line here, and this is the load. So there is some distance between the center line of the center line connecting the CG of the system and this applied load P. So because of this eccentricity, moment will develop. And what is the magnitude of that moment? The magnitude of that moment will be P times E, that is force times the distance. Okay, so that is the two things. Okay, so for this system, whenever a load is applied at some distance, so in this system there will be two kinds of forces. One is the direct force, that is simply in the downward direction, and another force is due to this moment PE. Okay, so in the next I'll explain what is the direction of that load. So direct force ka, so I've told you already that it will be in the direct same direction as P, and there will be some one another force which I'll explain in the next slide. Please stop me, okay, whenever you are like confused with any step. Okay, so first thing is clear. Second thing, I'm drawing the same system. This was in 3D, so I'm drawing the same system in 2 dimensions now. So this is the system of our bolt. Here is the CG, let's say. So this is the CG of our system, which is like this. And we have this applied load P, 10 kilonewton. Okay, so as I've told earlier, there will be two kind of forces which are generated. One is in the downward direction in each bolt, and another is due to the moment, that is due to P times this E. Okay, so let me connect this bolt with the CG. Let me connect all the bolts with the CG first. So this is our system. So another force will be, that is a force due to the moment, will act like this, that is perpendicular to the line joining CG and the bolt. Okay, so that force due to the moment will always be perpendicular to the line joining the CG and the bolt. And what is the direction of this arrow? The direction will be same as the direction of the moment. Okay, so in this system, this is the center line and this is the load. So this load is trying to rotate this system in which direction? Clockwise direction, right? So in clockwise direction, therefore the direction of this arrow will be along the clockwise direction. So this is the clockwise direction. Okay, I'll make it for another other bolt also. So for, like, let's say it's bolt number 2. So the direct one is the direct force I've already drawn. This is the direct force, and another is that due to the moment. So it will be perpendicular to the line joining the CG, this is the CG and the bolt, so it is perpendicular, and its direction will be in clockwise direction. So it is in such direction such that it is rotating the system in the clockwise direction. Okay, like I'll make it for the third bolt also. Let us say it's third bolt. So this is the line which is joining the CG and the bolt. So it will be perpendicular to it, and the direction will be clockwise direction. So it is perpendicular, right? And the direction will be clockwise direction. And what it will be for fourth one? It will again be perpendicular to the line joining the bolt and the CG, and the direction will be clockwise direction. So all these forces, let's call it as PD1, that is the force due to, sorry, PB1, that is the force in bolt 1 due to bending moment. Let's call it PB2, that is force in bolt 2 due to bending moment. This is PB3 and this is PB4. If you'll see all PB1, PB2, PB3, PB4, you'll see that they are trying to rotate the system in clockwise direction. Okay, and our applied load was also in clockwise direction. Okay, so this you should keep in mind. Another thing is, let's call this as PD1, that is force in bolt 1 due to direct load. Let's call it PD2. This is PD3 and PD4. So these are all the possible forces in the system. Okay, you do not need require to do all these things for in gate exam. I'm just explaining for the explanation I'm doing this. Okay, but in gate exam the question was you need to find the resultant force in bolt number 1 only. So you should consider this bolt number 1 only. All other you do not need to make. Okay, so I'm removing all other forces. Okay, so I'm just removing it. Yeah, so this only you need to consider forces in bolt 1 only. Okay, so just see it here. So it has one P D1 and one another which is perpendicular to the line joining the CG and the bolt, and its value is name is PB1. Okay, so I hope it is till now. Is there any problem? If there is any problem, you can write in the comments or ask me directly also. Okay, so now we have these two for, yeah, yeah. Okay. So PD1 is the force in the bolt due to direct stress. Okay, I'll explain it again. Okay. This P is at some eccentricity from this center line of the bolt. You agree, right? It is at some distance, 15 centimeter. Suppose if it would not been here, if this bolt would have been here, that is at the CG location. P is equal to 10 kilonewton. Okay, then what happened? Then only PD1 existed. PD1, PD2, PD3, PD3 and PD4. That is only direct forces would have been existed. No force due to bending moment would exist. Okay, in this case. So PD1 is the force due to this direct load, and PD2 is force which is generated whenever there is an eccentricity. Okay, I hope so. In this case, there will be no PB1, PB2, PB3, PB4, because PB1 generated only when there is moment in the system. Since this load is applied at the CG location in this case, so there would not be any moment here now. So only PD1, that is direct force exists. Okay, so PD1 is basically direct due to direct force, and PB2 is whenever there is some eccentricity in the system. Is it clear now? What is their value? I'll explain in the coming slides. Okay, so for now, so in this question we are asked what is the value of the resultant force in bolt 1. So resultant force means resultant of all the possible forces which are there in that bolt. So in our bolt 1, now we should consider only bolt 1. So in our bolt 1 there is one force which is PD1, that is direct force, and there is another force which is due to the bending moment, which I am calling it PB1. So I need to find the resultant of PD1 and PB1. Okay, because that is what is asked in the question. To calculate the resultant, first I should know the value, what is the value of PD1 and what is the value of PB1. So let's see how to calculate PB1 and PD1. Okay, so first is the direct force. So first of all, I'm calculating the direct force. So direct force will be simply PD1 will simply be equal to total or the applied load. I will call it applied load divided by number of bolts. So in this case, how many number of bolts are there? 4, right? So it will be 4 here. So PD1 is very simple to calculate. What is the value of applied load we have? The applied load is 10 kilonewton. So we have 10 kilonewton divided by 4. So we got the value of PD1 simply as 2.5 kilonewton. Okay, all the bolts will have same value of direct force. All the PD1 will be equal to PD2, will be equal to PD3, will be equal to PD4, and all of them will have a value of applied load divided by number of bolts. That is 10 in this case divided by number of bolts were 4. So PD1 comes out to be 2.5 kilonewton. Very, very simple to calculate. We do not need to worry about direct force. Direct force will always be simply applied load divided by number of bolts. Okay, that is okay. So this thing is the second thing, which needs some calculation, is the force due to the bending moment. So how to calculate the force due to bending moment? Let's see. That is PB1 we need to calculate. PB1 will be equal to, it is very similar to that formula. That is the force due to the bending moment we calculate, right? Stress due to bending moment we calculate like m by I into y. It is very similar to this formula. The formula for calculating the the force due to bending moment is PE, that is the moment, P into E divided by summation of Ri square into R1. Here we need to calculate the force due to bending moment in load in bolt 1. So we'll write R1 here. If we need to calculate the force in bolt 2, then we would write like PE summation of Ri square will be, till now there it will be same, and then we'll multiply it with R2. Similarly, if you want to calculate it for PB3, the formula would have been PE divided by summation of Ri square multiplied by R3. Okay, so this term will remain same, only this term will vary according to which bolt we need to calculate the force. Okay, so in this case we need to calculate the force due to bending moment in bolt 1. Therefore we will use this formula. So this formula, please remember this formula, or write it in your formula diary or something which you have made. Okay, so it's very important. PE summation of Ri square into R1 or R2, whichever bolt you need to find the value of force. Okay, so PB1 now we'll put all the values. So PB1, let's see, P we know, right? P is the applied load. P is 10 in this case. What is the value of eccentricity we are given? Eccentricity value is 15 centimeter. So let's keep it in centimeter only, 15 centimeter. And what is summation of Ri square means? Summation of Ri square means R1 square plus R2 square plus R3 square plus R4. There are 4 bolts, right? So R1 square, summation of all R squares. So R1 square plus R2 square plus R3 square plus R4 square multiplied by R1. Okay, so this formula will write it like this. Very simple, just you need to remember this formula. Okay, now we will put all the values here. Okay. So we want to calculate PB1, so we will write P into E, so 10 into 15. What is the value of R1, R2, R3, R4? Let's see. Okay, so here in this case, this entire length is given as 10 centimeter, right? So this is half of it, so it is 5 centimeter. 5 centimeter, all of them are 5 centimeter. This is also 5 centimeter, this is also 5 centimeter, and this is also 5 centimeter. All of them are 5 centimeter. Okay, so this length, half of this length. Okay, so this length is 10 centimeter, so half of them 5 centimeter, 5 centimeter. Okay, so R1, R2, R3, R4 all are 5 centimeter. Okay, so if I want to write 5 square plus 5 square plus 5 square plus 5 square, or I can write 2 into 5, 4 into 5 square, right? Multiplied by, what is the value of R1? R1 is 5. I hope it is fine. So PB1 value we got the answer as 7.5 kilonewton. So this is the answer we get for PB1. I hope you don't have any confusion till now. So we have calculated PD1 and we have calculated PB1. Okay. So for this bolt, that is bolt number 1, we have calculated the direct force as well as the force due to the bending moment. Now we will calculate. So in this question we have asked to calculate the resultant force. So we will calculate the resultant for direct force and the bending force. Let's see how to calculate the resultant force. Yeah. So the resultant force, the formula for the resultant force is F resultant is equal to F1 square, simply the resultant of two vectors which you must have studied in your 12th class also. So F1 square plus F2 square to F1 F2 cos theta. So this is the formula to calculate the resultant of both the forces. So in this case, the two forces we have are FD1 and FB1, right? So we can write it as FB1 square, or FD1 square plus FB1 square plus 2 FB1 FD1 cos theta. FB1 we know, FD1 we have already calculated. The only thing we need to calculate is the value of theta. If we know the value of theta, we can easily put all the values in this formula and we'll get the answer. Okay, so let's see what is the value of theta here. So theta is basically the angle between both the forces. Okay, so here we have the two forces at FD1, sorry, PD1 and PB1. So the angle between these two is, this angle is 90 degree, we know, and this angle is 45 degree. The entire angle is 90 degrees, so half is 45 degree. Okay, so then the total angle between these two things will become 90 plus 45 degree. So theta will become 90 degree plus 45 degree. So theta will be equal to 135 degree. Okay. So in this case, so I should write P instead of F. Okay, so it is PD1. Okay, so we'll put all the values in it and we'll get to know the value of resultant force. So we have, what is the value of PD1 we calculated? The value of PD1 we got was 2.5 kilonewton. So we'll write 2.5 kilonewton plus, what is the value of PB1 we got? PB1 was 7.5 kilonewton. So it is 7.5 kilonewton plus twice of PB1 multiplied by PB1 into cos 135 degree. So value of resultant we got was, is finally the answer we got is 6 kilonewton here. Okay, so I'll again quickly revise this question. Okay, so first of all, yeah, the answer we need to fill here is 6. Okay, so what did we do in this question? In this question, there was a column and one bracket plate. We have one applied load P which was at some distance from the center line or from the CG location. Okay, so then what did if we got to know that because of this load we will have two kind of forces in each bolt. First is the direct force, which will have the same direction as the applied load, and another will be the force due to the moment. Okay, so and the direction of that force, that is the force due to the moment, will be perpendicular to the line joining the center line and the CG. So its direction will be like this. So these two forces we will calculate these two forces, that is direct force and bending force. Then we will find the resultant of those two things. So first step is to find the direct force. So this is step number 1. Okay, this thing you should just keep in mind for gate. Okay, so first step is direct force calculation. So direct force will calculate using this formula, that is applied load divided by number of bolts. Second step is, so this is step number 2. So second step is find the force due to the bending moment. So the formula for the same is this, that is PE divided by summation of R square RI square multiplied by RI, or the or R1, whichever, whichever bolt you need to find the thing. Because so two steps are clear. First is the direct force calculation, second is the force due to bending moment calculation. What is the third step now? Third step is this, that is find the angle between the direct force and the bending force. In this you need to use a little knowledge of geometry. For example, in this case this was our bending force and this was our direct force. So this angle we already know because this is the, so the angle between the bending force and the line connecting CG and bolt is always 90 degree. We know that. So this angle we know it is 90 degree. So this angle, either this angle will be 45 degree. Why? Because the entire angle was 90 degree. This angle, entire angle was 90 degree, and this was half of it. So it will be 45 degree. So theta will we got as 135 degrees. So this is step number 3, that is angle calculation. And finally fourth step, that is step number 4, is the resultant force calculation. For this you need to keep this formula in mind. Okay, so whenever you are making notes for this type of problems, just write the question. Okay, so write the type of question you are calculating. So the topic will be resultant stress in bolts, and how to solve it. You'll write 4 steps: step 1, step 2, step 3, step 4. What will be this first step? First step will be direct force calculation. Write the formula in front of it. Second step will be the force due to bending moment calculation. Write the formula in front of it. The third step will be angle calculation, and you need to use the knowledge of geometry for it. And step 4 will be resultant force calculation, final step, and this is the formula for it. Okay, so for this type of question, in every question you need to follow these 4 steps and you will get your answer. Okay, just some practice you require for it. I hope it is clear. Any problem in any step you can ask me. Is it fine? Can I move towards the next question now? Okay. In the next question, you will see that again the similar question came in GATE 2018 also. Okay, very similar question. So in this question also there are 4 bolts which are given to us. Yeah, so 4 bolts are given to us, and the applied load is 130 kilonewton, which is at a distance of 200 from the CG of from the line connecting the CG of the system to the applied load. And there are 4 bolts which are given P, Q, R, S. So these 4 bolts are connecting, which are given. Okay, so and another thing which is given is, yeah, so we need to calculate the force in bolt P. Here we need to calculate the force in this bolt, that is bolt P. Very similar question. Okay, so here also we'll follow the same 4 step. What was our step number 1? Step number 1 was direct force calculation. So step was direct force calculation. What was the formula for direct force calculation? Let's say in this question we need to calculate force in bolt number P. So okay, we can write it PDP. Okay, you can name it any way you want. So force, direct force in bolt number, in bolt P. So the formula will be applied load, that is 130 kilonewton, divided by number of bolts. What are the number of bolts here? 4, right? So step 1 is same. What will be the step number 2? The step number 2 is bending force calculation, or the force due to the bending moment, that force calculation. The formula for it will be, we can call it PBP. So force in bolt P due to bending moment. So formula will be PE divided by summation of Ri square multiplied by Rp. That is the distance between the CG to the bolt P. Two steps are clear, and step number 3 will be, step number 3 is angle determination. So angle between this PDP and PBP. That is step number 3. And what is step number 4? Final step. Final step is the resultant force calculation, and the formula for it is F, sorry, not F, I'm named it P dP square plus PBP square plus 2 PDP PBP cos theta. So every question, this type of question will follow these 4 steps only. You just need to remember these 4 steps and just put the values and get the answer. Okay, I hope it is clear. The next thing is, so we'll follow these steps. So first is direct force calculation. So we have named it as PDP. So it will be the applied load, which is 130 kilonewton in this case. So 130 divided by number of volts, that is 4. So the value of P dP we got is 32.5 kilonewton. Simple, right? Very simple. Second step is force due to bending moment calculation. Let's do it. It will be P BP is equal to PE divided by summation of Ri square into Rp. PBP will be, what is the value of P? That is applied load, is 130. What is the value of E? Value of eccentricity is given as 200 mm. So it will be 200 mm divided by summation of Ri square. So summation of Ri square means Rp square plus Rq square, sorry, plus Rq square. What are all the things? PQRS, right? Plus Rs square plus PQRS, okay, RR square multiplied by, in which bolt we need to calculate, in Rp. So Rp. So this formula will become like this. So then we need to know the value of Rp, Rq, Rr and Rs. Let's see what are these values. Yeah. So this is the CG line. This is RQ. This is Rp. This is Rs. And this is RR. So what is the value? All the 4 are same, right? So let's calculate any one of them. So this length we need to calculate, that is Rp we need to calculate. What is the value, what is this length? Vertical length, this is 240. Then this entire length is 240. So this length is 240 divided by 2, that is 120. Since this entire length is 100, so this length is 100 divided by 2, that is 50. So now we know vertical, now we know this horizontal 50. Can we calculate the value of hypotenuse? The value of Rp will be under root of 120 square plus 50 square. So value of Rp we got as 130 mm. Simple Pythagoras theorem we have used here. Okay. So this type of values, either they will directly give you the value of all the R's, or you need to calculate it like this. Simple geometry. Okay. So now we know the value of Rp, Rq, Rr, everything, because all are same here. Every distance is same. So you can calculate any one of them. Okay. So what is the value of PB now? The value of PB, PBP will be equal to, will be equal to 130 multiplied by 200 multiplied by, what is the distance of RP we have calculated? We have calculated RP as 130 divided by, this we can also write it as 4 into 130 square, because, or either you can add it. So 4 into 130 square. So this 130, these two 130 cancelled out with this. So you can calculate PBP comes out to be 50 kilonewton simple. So this is the value of PBP we got. Okay, so now we know the value of PDP also and PBP also. What is the step number 3? Step number 3 is angle between PDP and PBP. So what is the angle between these two things? Okay, so let's draw it clearly. So this is the CG, this is the R value, this is the PDP direct force, and what will be the direction of PBP? The value of force due to bending moment will be perpendicular to the line joining CG and the bolt, so it will be here. So what angle we need to calculate? We need to calculate this angle theta. Okay, so this angle we need to calculate. So to calculate this angle, there are different methods. You can use any of them, but I'll use like this. So this angle, I'll call it, if I can zoom it, okay. So this angle, I'll call it theta 1. Okay, so theta 1, if I know, if I'll calculate theta 1, what will be the value of theta? Theta will be 90 degree minus theta 1, because this entire angle was 90 degree, right? So theta will be 90 degree minus theta 1. So let's calculate theta 1. Theta 1 is simple to calculate. We can use any of them, like we can use sine theta maybe. So sine theta 1, sine theta will be perpendicular divided by hypotenuse. So what is the value of perpendicular? The perpendicular value is 50 mm, right? This value is 50 mm, right? Because we have already calculated it's 50 mm. And what is the value of this hypotenuse we got? The value of hypotenuse we got as 130 degree. Sorry, 130 mm, right? This H or RP was 130. So theta 1 is equal to sine inverse of 50 divided by 130. Okay, so what is the value of it we are getting? The value of this angle theta, yeah, so we are getting the value of this theta 1 as 22.619 degree. You can try to calculate it. And so the value of theta will be 90 minus theta 1, 90 minus 22.619. The value of theta we got as 67.38 degree. So this way we can calculate the value of this theta, which is 67.38. What is theta actually? Theta is the angle, just let me rub it. So theta is basically the angle between P direct force and the bending force. So this angle is theta that we need to calculate. You can use any method. If you want to do some other way, you can do that, but this is one of the method in which you can calculate the value of theta. So we got the value of theta as 67.38 degree. Okay, so now we got the value of angle also, that is 67.38 degree. So now we will use the resultant formula. The resultant formula is PDP square plus PBP square plus twice of PDP into PBP cos theta. So everything we know now. So we'll calculate the value of FR as under root of 2.5 square. Sorry, what is the value? Oh, sorry, 32.5. 32.5 square plus 50 square plus twice of 32.5 into 50 into cos theta. So cos of theta 67 point whatever we are getting, cos 67.38. So the FR value comes out to be 69.3267 kilonewton. So this is the value we are getting. So out of the options we are getting the answer as option number B, that is 69.32 kilonewton. Okay, so the critical thing is, not the critical, in which you need to use your mind a little bit, is the angle calculation. Otherwise you just need to remember all these formulas. Okay, every question have these 4 steps only. Just follow these 4 steps and you will get the answer. Let's try to do one practice problem now. So this problem, it's very similar to those we were doing now. Okay, so in this question, there's a column which is subjected to a load of P at an eccentricity of 100 mm. So eccentricity value, given values are, eccentricity value is given as 100 mm. What is the value of applied load? P applied load is 60 kilonewton. Okay, and other things are the geometrical, other things are given to us, that is the distance between different things. Here the CG of the bolt will lie here at the center. Okay, so here is the CG of the bolts. But in this question, the only different thing is all the R's are not same. For example, this is RP, this is RQ, this is RR, this is RS, this is RT, and this is RU. So all the R's are different here, right? For example, RR, that is this one. So RR value, RR is 40 mm, right? It is given. RR is 40 mm. Similarly, RU, this is RU. RU is also 40 mm. But RP, RQ, RS, and RT are different. So this is RP, this is RQ, this is RS, and this is RT. So RU and RR are 40 mm, it is given. What is the value of RP? We'll again use the Pythagoras theorem here. So RP, this distance is given to us, which is 40. This distance is given to us, which is 30. How we'll calculate RP? RP will be under root of 30 square plus 40 square. So in this way, we will calculate the value of RP in this question. Okay, so the only different thing was that all R's are different, because earlier in all the other questions we did, the R value was same, so we were just simply writing 4 into R square. Okay, but in this case, we have to add them separately. That is the only difference here. Other than that, everything is same. Okay, another important thing for this question is, okay, maybe I'll use some other, yeah. So another important thing for this question is, what is the direction of the bending force and the direct force. So in this question, we need to calculate the value of force, resultant force in bolt R. So let's see what are all the forces which are acting in bolt R. So in bolt R, one will be the direct force, which I'm calling at FDR, and another will be the force due to the bending moment. Okay, so the force due to the, what are the two criterias for writing the force due to the bending moment? So the first criteria is it should be perpendicular to the line joining the CG of the bolt and that bolt. Okay, so this F, let me remove FDR for a moment. So let's remove this. Okay, so the force due to the bending moment should be perpendicular to the line joining these two points. Okay, so let us draw. So it will be like this: F or P B R. It is perpendicular to this. Okay, because this line is horizontal, so perpendicular line will be this only. And another thing is, it should be in the same, it should rotate the system in the same direction in which the applied moment is. So in this case, the applied moment is trying to rotate the system in clockwise direction, so all the bending forces will be aligned accordingly. Okay, for example, let me draw here. So here p dr will be like this, and pbr will be like this. pbr. For this bolt, sorry, for this bolt, if this is the value of, this is r, so direct force will always be downward. Okay, so pd, whatever its name, let's call it 4 for this case. pd4 will be like this, and pb4 will be like this. It will be perpendicular to this line, and its direction will be such that it is rotating the system in clockwise direction. So it is pb4. So I hope you understand. But the main thing is that in for bolt R, both PBR and PDR are in downward direction. PDR is always in downward direction for every bolt, but for bolt R, even PBR is always also in downward direction. Please let me know if you do not understand this concept for bolt number R. Why all the both the things are in same direction? Harini, is it clear, or I'll explain again? Otherwise. Clear, right? Okay, it's not that much tough. Okay, so in this case, it's in that sense it is very simple now. So in this case also we have to follow those four steps. Can you tell me the value of direct force for bolt R? That is step number one. Yeah, that is applied load. What is applied load? 60 kilonewton. 60 by why 4? Uh, yeah, yeah. Not always 4, right? In this case, 6 volts. Yeah, very good, very good. So PDR will be 10 kilonewton. First step is clear. Can you quickly tell me the step number 2 also? Let's do it together. So step 2 will be P E R R divided by summation of all R's. So let's call it 1, 2, 3, 4, 5. Other than R, let's name them as 1, 2, 3, 4. So R1 square plus R2 square plus R square plus R3 square plus R4 square plus R5 square. Just for simplicity, I've named it like that and like this. Hmm. Now, let's put all the values. What is the value of P? P is 60. What is the value of E? E is 100. Okay, what is the value of RR? The value of RR is, this length is 40 mm. So it is 40 divided by, what is R1? This length. Just now I have calculated. So R1 will be under root of, that is I have used Pythagoras, under root of this length plus this length. This length is 40, this length is 30. Right, so 40 square plus 30 square. So R1 value we got as, what is the calculation saying? Let's calculate it. So what is the answer you're getting finally? Just tell me that, okay? Yeah, this is 50, and you just calculate all the other things also. Just put everything in here. Final value of PB1. So you need to solve this whole thing. So are you getting 18.18? So yeah, so FD1 we have already calculated, sorry, FDR in this case. So FDR we calculated as 10. FBR you calculated, you told me, as 18.18 kilonewton. So since both of them are in the same direction, we do not need to apply that resultant formula. So if you can directly add them, okay. So one way of calculating is, since both of them are at in same direction, you can simply add 18.18 and 10. So your resultant answer will be 28.18 kilonewton. If you want to use the formula, then you can, so since the angle between those two was 0 degree now, right? Because they are in the same direction. So even if you use the formula, you'll get the same answer. First, PDR square plus PBR square plus 210 into 18.18 into cos 0 degree. Cos 0 degree is 1. So this, in this way also you'll get the same answer as 28.18 kilonewton. So this is the answer you're getting. Okay, so this is the answer for this problem. And this problem, okay, just this thing simplified, that is the both were in the same direction, but here the value of r was different for every bolt. Okay, that is the only thing. So I hope this type of question is clear. So I'll cover this question maybe some other time. Okay, because time is less. Okay, so is there any problem? This type of question can you do? Acha, why? Oh, okay. Because in this case, as I have told, that both PBR is in downward, sorry, PDR is always downward. Okay, PDR is always downward, but in this case, PBR was also downward. So in this case, suppose this is the bolt. Okay, suppose this is the bolt. So PBR was in, this is PDR is always in downward direction. But in this case, what happened is PBR was also in the same direction. PBR was also. So the angle between these two is now 0 degree. Okay, or so in this case, you can either add both of them. For this bolt, that is bolt number 2, the angle is not 0 degree. Angle is, there is some value of angle. For this bolt also, there is some angle here, right? Like this, there is some angle. For similarly for this also, there is some angle between PBR and PDR. But for this case, both the PBR and PDR are in the same direction. So either we can add both of them simply, or if you want to use the formula, you can use theta is 0 degree, because both of them are in the same direction. Okay, so this is, if these two forces are in the same direction, this is 0 degree. Okay, so this, if these forces are in the opposite direction, this is 180 degree, right? Like this way. Okay, is it clear now? Okay, so can you do these type of questions now? So just practice, just find these type of problems in previous gate years and try to solve using these 4 steps. And if you are sure, then you can write it in your notes diary or something you have made. Okay, so now then, every time you are solving these type of problems, just follow these 4 steps. Okay, just these 4 steps should click on your mind, and you need to put the values and solve it quickly. Okay, so these are the small tricks you should use. Okay, just because at that time have a lot of things in your mind. So if you can just see this type of problem, these 4 steps should come in your mind. So that should be the level of your practice if you want to crack gate. Okay, so these things you should keep in mind. Is it okay for today? Oh, okay. In the next week, maybe I'll be covering static and kinematic indeterminacies for beams and frames and everything. Okay, then thank you so much for listening. I'm closing the session for today. Have a good day.